But then let's move to the next one. Okay, we move now. Just now we settle for the overall boundary, so now we move to a smaller parts. Okay, so we start first with, okay, so I draw back again the evaporator. Okay, so now we're going to do some material balance for this boundary. We're going to do some material balance for this boundary, which is on the splitting point. Okay, so remember what stream involved here. This is only M1, M2 and M6. So these are only the streams that is involved here. Okay, so let's have a look at the what are the information given here. So we know that it is 0.12 solid, 0.88 water. So similarly here, 0.12 solid, 0.88 water, and M6 also have the same, 0.12 solid, 0.88 water. So what is the balance that we could write here? So here we have M1 is actually 100. Okay, so we will have 100 equals to M2 plus M6. Okay, so this is M2 plus M6. So that is one equation we have. And we have for solid balance, it is 0.12 multiplied with 100 equals to 0.12 M2 plus 0.12 M6. Okay, and then for water as well, if we write 0.88 times 100 equals to 0.88 M2 plus 0.88 M6. So how many independence equation that we actually have? We only have one independent equation, because you can see that both of this term repeated each other again. M2 and M6 still appear here, M2 and M6 still appear here. So if you try to substitute everything, you will not be able to solve the problem. Again, you can see that the composition is the same, so you will not be able to solve the problem. So only here we only have one independent equation. But how many unknowns we have? We have two. So this is not yet solvable until we solve some other equation. So degree of freedom is equals to 2 unknowns minus 1 independent equation. So you have 1 here. So this is not solvable yet. Let's have a look at the next material balance that we could perform. So we have here, this is evaporator again. Okay, and then we have the bypass, right? So what we're going to solve right now is only this part. So what is the stream that involved in this part is actually M2, okay, M4 and M3. So how do we write the balance for this? So we know that for overall balance, it is M2 equals to M3 plus with M4. Okay, that is 1. What else do we have? We have for solid, okay, we have here, this is 0.12 M2 equals to 0, okay, because we do not know what is actually we don't have solid at all in the evaporator together with water, except and in M4 we have 0.58 M4. This is given. Okay, the information given is 0.58 solid, 0.42 water. And then this is for solid, and then for water we have 0.88 M2, which is equals to M3 plus 0.42 water. Okay, so let's see how many independence equation we how many unknowns we have here. So altogether we have 1 unknowns, 2 unknowns and 3 unknowns. But how many independent equation that we have? So we have one equation with all the three terms appear. Okay, this is one, right? And then we also have this is supposed to be M4. Okay, so we have the next equation also have three unknowns here together in this stream, which is in water. So this is not independent equation, but we have this as independent equation. Okay, so we have the solid equation here. So we have two independent equations, but we have three unknowns. Again, 3 minus 2 equals to 1. So degree of freedom is equals to 1. Still, this is not solvable yet. So we need to actually move and provide and do another material balance, which is for the mixing point. So in the mixing point, okay, so this is the mixing point. So in the mixing point, we want to do the material balance, which involve M4, M6 and M5. So how do we write the balance? So it is M4 equals to it is supposed to be M5 equals to M4 plus M6. Okay, because this is the direction here. The total up from this point and this point make up M5 stream. So that makes sense, right? M5 should be bigger than the stream, the values in M4 and M6. That is one equation. The second equation, because we know that this is 0.58 solid, 0.54 to water, but outlet of here is actually 0.42 water, 0.42 solid, 0.58 water, and here you have 1.12 solid and 0.88 water. So we have one equation here. Okay, and then what is the next equation? The next equation, it is with regard to solid. So what can we do for solid? Solid is actually 0.42, okay, 0.42 M5 equals to 0.58 M4 plus 0.12 M6. Okay, so this is another equation. And then how about water? So for water, we also have 0.58 N5 equals to 0.42 N4 plus with 0.88 M6. Again, when we do the balance, we know that there are actually three unknowns, M5, M4 and M6. But again, you can see that this equation also appearing, all these variables appeared here. So we cannot say that we have to choose either solid or water to become one unknown independent equation. Okay, because another equation is dependent to it. So let's say we pick this one. So there are actually two independent equation. There are three unknowns. So 3 minus 2, you got 1. So this is still not something that is solvable. So what you have to do is actually, when we have a look at overall, okay, when we write down overall balance, we could see that the first one, okay, the first one which is with regards to overall boundary, okay, those are the first one that we could solve first, okay, because this is, let's say this is M1, this is M3, this is M5. So we'll be able to solve this one first because the degree of freedom equals to 0. Once you got the value, for example right now, after you solve this overall balance, you'll be able to get M3 as well as N5. So you can resubstitute back in any of the information or equation that we have developed earlier. For example, in this case, okay, in the latest case at the missing point, you know the value now of M5. So we can easily substitute the value of M5. And from here, we can easily substitute we can solve simultaneously this equation, and you'll be able to get the value for M4 as well as M6. Okay, so once you got for value for M4 and M6, only then you'll be able to solve the problem, the equation that we have developed in the past for other smaller boundary system. Okay, so this is very simple way of solving material balance with regards to bypass and recycle, and I hope that by doing this you'll be able to solve the problem as a whole. Okay, so thank you very much. Take care. See you again in the next video. Bye.